All right, so quick review of areas if you want to add them onto that little cheat sheet that I gave you. Number 1 is what shape? A pyramid, and specifically a square pyramid. Good. So I know the volume would be 1/3 the base area times the height. The base would be a square, so the B itself is going to be 6 squared, or 6 times 6, which is 36. And then it gives you the height, which would be 8. 1/3 of 36 is 12, and 12 times 8 is 96 inches cubed because it's volume. Good. So picture this now with an area question. Okay, so there's 4 shapes on your quiz, and each one's going to ask for lateral area, total area, and volume, so you can kind of get an idea. Okay, one prism, one pyramid, one cone, one cylinder. So if I wanted to know slant height on this, what do you have to do? Good. So I can make this into a little, whoops-a-daisy, a right triangle that consists of half of the base. So this would be 3, the height, which is 8, and then I have to find slant height by using the Pythagorean theorem, and then I can find all the other stuff that you need to know, okay, for surface area and for lateral area.
Is it going to be like a square pyramid or
It won't be a hexagon. It could be a square or a triangular one, so they're both on the review. Be a good idea. On Friday we talked about the volume of a cone and the volume of a pyramid. What's the formula for the volume of the pyramid? 1/3, good. Base area times the height, good. And then the volume of the cone, we added, the base would have been a circle, right? So 1/3 pi r squared h. So you should have all that stuff filled in on that little cheat sheet minus the spheres stuff. There is a Quizlet that includes all that stuff. It also includes the spheres. So you can just ignore those 2. The spheres won't be on your quiz, but they will be on your test, so that's why it's all grouped in there.
Did you learn spheres on Friday?
No, we learned volume of pyramid and volume of cone. We're going to do spheres on Wednesday. All right, so number 1. All right, now we've got what shape? A cone. So the cone's volume is 1/3 the base area, which is now pi r squared, times the height of the cone. This one gives you all the information you need. So 1/3 times pi times 12 squared times 24. So 1/3 pi times 144 times 24. I can do 1/3 of 24, which is 8. 8 times 4. 1,152 millimeters cubed. Again, think about this in terms of area. Would you be able to find the area of this same shape? We'd still be missing slant height, right? Because the slant height we need for the areas, but you do the same thing, Pythagorean theorem, okay? And the only other thing that like jazzes it up with a cone is maybe they give you the whole diameter, so I'd have to cut it in half to get the radius. So those are the only other variations really we've seen on cones.
Oh, wait, you need this slant height for what?
You need the slant height for area. So you're going to have to find for for pyramid and cone, you're going to have to find height and slant height because you're doing the area, the lateral area, and the volume. Number 3 says find the volume of the cone, of the cube after the cone's been removed. So I need 2 things. I need the volume of the whole cube, and then if I took out of it the volume of the cone. So I'm going to find the volume of the cube and subtract from it the volume of the cone. So the cube we have a shortcut for, right? Good. So 6.8 times 6.8 times 6.8, which is 314.432. Because the volume of a cube is side cubed. Then you've got the cone. So for the cone, 1/3 the base area. So the base is still a circle even though it's upside down. Oh, Alexa, sorry. No, the cube, the volume of a cube is side cubed. It's length times width times height, but they're all the same. The cone and the pyramid are the ones you do 1/3 of.
Oh.
But the cube is just like a prism, right? All right, so volume of the cone would be 1/3 pi r squared times h. So I know if this whole side is 6.8, that the radius would be 3.4, and then the height, which is going to be the same as the vertical distance here, would be 6.8. So then I would do 1/3, I'm doing 3.4 times 3.4, 1/3 pi 11.56 times 6.8. Something like this is not going to be on your quiz. If it's on your test, you'll have your calculator, so that's the good news. 26.202, so 26.2 pi is the volume of your cone. So then I want to take the volume of my cube and subtract from it the volume of the cone. So with a calculator, you would probably do 26.2 times, so this is a good standardized test question, 26.2 times pi, which is 82.309, and then I would subtract that from 314. So 314.432 minus 232, minus 82.31, which is 232.1 millimeters cubed. So that's a great standardized test question because it's going to test your knowledge on the volumes and then also what can you do with them. So apply some basic knowledge with those. Questions on that one? Okay, then the volume of a right cone with a height 32 and a radius r is 2,144.66 inches cubed. Find the radius. So I can draw it, don't need to, okay, because it gives me everything I need to know, but the r would be here. The height is 32, and then the volume, which is 1/3 pi r squared h, equals 2,144.66. So what's one of the first things that you could do? Because there's a couple different ways you could do this, a couple different orders you could do. I could divide both sides by 32. So I'd get 67.02 equals 1/3 pi r squared. Then what?
Times each side by 3.
Good. Get rid of the 3. Multiply by 3. 201.06 equals pi r squared. Evan? Divide by pi. 63.9999, so it's 64. And then, last thing I got to do, square root it. So typically when we use algebra skills, we would have said this is plus and minus the square root of 64. But is there such a thing as a radius of -8? No, so we rule out the negative and we keep the positive. Questions on any of the warm-up? Okay, so flip to the homework. So the quiz tomorrow is covering lateral area, surface area, or total area, actually. I wrote total area, so I should be consistent. Total area and volume of prisms, cylinders, pyramids, and cones. So, I mean, obviously you have to know all 3 formulas for each of these. So it's 12 total formulas. And then the ones like a cube and a rectangular prism volume are just to help you out, okay? You can survive as long as you can decipher the pyramid one, the prism one, without those, but obviously it makes your life a little bit easier. So first, make sure you can draw these out. If it gave me the length, the width, the height of a prism, they don't have to be perfect, but you do know how have to relate them to the side lengths. So I would draw myself a rectangular prism, length, width, height. And then you would want to be able to find the lateral area, which is the perimeter of the base times the height. the total area, which is going to be 2 times the base area plus the lateral area, or 2 times the base area plus perimeter times the height. And then the volume, which is the base area times the height in a rectangular prism, that's length times width times height. And in a cube, it's side cubed. Then we went to cylinders. Which is just like a prism, but with a circle as its base. This would be my radius, and this would be my height. Lateral area on a cylinder, because perimeter on a circle is 2 pi r, right? That would be my circumference times the height of the cylinder. The total area is 2b plus ph. Since the b is a base of a circle, this is 2 pi r squared plus the lateral area, or 2 pi r squared plus 2 pi r h. And then the last one is volume. Base area times height if it's a prism, which means pi r squared times h if it's a cylinder. So hopefully the cylinders are the easy ones, right? There's not a whole lot of guesswork there. You just got to get the formula right. If they gave you the diameter, you'd cut it in half. That's pretty much all you'd need.
What was the lateral area for a prism?
For a prism is perimeter times the perimeter of the base times the height. Burrell.
There's like a side or something not given. Like, what are the things you use? Like diagram, 45, 45,
Yeah, I mean, that's pretty much it. Your Pythagorean theorem, your 45, 45, 90, your 30, 60, 90 are kind of the only things that you can do without a calculator, which you won't have. I didn't put a hexagonal prism on there. There's one on your review because it might come back for your test. So you would use that as a 30, 60, 90 triangle, find the area of the base that way, but I didn't put it on the quiz. All right, then we had pyramids. So pyramid, you could see one of 2 different types. One is a square pyramid. If they gave you the side of the base, it would be one of these measurements, okay? Or a base edge, those are the same things. The slant height would run down the side here. And then the height of the pyramid would run straight down the middle. So in a square pyramid, 1/2 the side, the height, and the slant height, make yourself a little right triangle. So lateral area on a pyramid is 1/2 perimeter times the slant height. So the perimeter of the base, if it's a square, is just going to be the length of each side times 4. And then either the slant height or the height would be given, and you're going to find the other one. God bless you. The total area, there's only one base here, so it's B plus the lateral area, or B plus 1/2 perimeter times the slant height. So the area of this base would just be side squared because it's a square. Alexis. Yeah, I mean, once you've already found the LA, you're going to have to anyways. Then I would just use that formula, B plus LA, every time.
Is it gonna be like everything's connected? Like first you do like for one whole like thing.
So each shape is 3 questions within the one shape. So you're going to have 1 prism, 1 pyramid, 1 cone, 1 cylinder. If you get like the perimeter wrong and you carry it down wrong, I'm not going to take off all the credit. You'll lose a little bit, but I'm not going to take off all the credit. Does that make sense? If you get lateral area wrong, so then you lead to getting total area wrong, I'm going to take that into consideration. You won't get all of the credit, but you won't get none of it either, okay? All right, and then the last one is volume, which is 1/3 base area times height. And again, you should have already found the base area because you'd used it for total area. Yep.
Is the little like segment between the height and the slant height, is that 1/2 like one of the sides?
That is correct. Yep. This would be 1/2 the side length on a square pyramid. So I'm going to draw a triangular one in a minute.
Is it also half the height or just half the side?
No, because you could have a really tall pyramid, right? Or a really short pyramid. It has no relation to the size of the base. But those do make a right triangle. So now let's say you had a equilateral triangle as its base. So the height still runs from the center on the top straight down to the center on the base. This time when I go to find the perimeter, it's going to be the length of the side times 3 because it's an equilateral triangle. When I go to find the area, well, let's do slant height first, right? If I want to find slant height, this is the apothem mixed with the slant height. So I'm going to eventually, if it's an equilateral triangle, have to find base area, which is 1/2 ANS, if it's an equilateral triangle. Or I can make my equilateral triangle into two 30, 60, 90 triangles. So you could look at it either way. Yep.
Is that going to be on the test?
The quiz or the test?
The quiz.
I said you could either have a square pyramid or you could have an equilateral triangle pyramid.
So what's the difference if you do the ANS
Versus the 30, 60, 90.
Yeah.
So the base, if I pull out the base here, let me flip it upside down so it looks just like it. This is the base, right? If it's an equilateral triangle, this is 60, this is 60, this is 30, this is 90, right? If it gave me the slant height, well, you still have to find the apothem either way. You either have to know the apothem or the radius in order to complete that triangle.
Oh, how do you find the apothem?
Use your central angles. So we'll go back to your central angles, where this would be 360 divided by 3, which is 120. Top angle is 60, 30, 90. So you'll probably get given like the side length, cut it in half, and use that to find the apothem.
Which one's the apothem?
The apothem goes from height to the bottom of the slant height. So it's this little segment here.
So when you're saying it's an equilateral triangular pyramid, you're only referring to the base?
Correct. Yep, good question. Only the base is the equilateral triangle. The other triangles are isosceles, but not necessarily equilateral.
They're always isosceles?
In a regular pyramid, the sides are always isosceles, because every time you go from the top down to a side, those are all going to be the same length.
And they're all going to be regular?
Yeah, Lourdes?
Are you gonna give us like crazy numbers?
No, I don't think they're that bad. I think you should be able to handle them. Yep.
Do you apothem half the side length?
No.
36.
In a square it is, in a triangle it's not. So think about what happens if I look at this top one. Like the apothem goes only to the edge where the radius goes all the way to the vertex. So if I look at the side length here, it's way longer than this little segment here. Does that make sense? It's in your A root 3 to A ratio, so it's not the same. In a square it is, because it's a 45, 45, 90 triangle when we cut it. So both the legs are going to be the same.
What do we do if you give us like the radius to find the apothem?
If I gave you the radius, and well, if I gave you the yeah, you'd still have to find the slant height. So you just have this length instead. That would be your 2A side. And then you'd still work backwards. So you'll either get the side length, you'll probably get the side length though, because you have to use it for the perimeter. Yeah.
Wait, so for triangular pyramid, you use 1/2 ANS?
Just to get the base area, yeah. Well, I mean, and really you could find the area of the triangle without it, but you can't find the slant height without knowing the apothem, because it goes from the bottom of where the height hits out to the side, which is your apothem.
I get it. That's the only problem we're going to use
Yeah. You know hexagons. I didn't put the hexagons on here. Yeah. Okay, questions? So that little triangle that's formed, this is going to be the apothem of the base. This is the slant height, and this one's the height. So that's the other little right triangle that's formed. And then cones, I think we get back to where it's easier, right? Pyramids are the worst. Okay, cones, if you drew it out, and again, it doesn't have to be perfect. This is my radius, this is my height, and this is my slant height. So with a cone, you've got a little right triangle. You're going to get given 2 of those 3 things. You'll find the third. The lateral area is 1/2 the perimeter, which is now circumference. So the 1/2 and the 2 cancel out, and it's just pi RL. Total area, there's only one base, and it's a circle, so it's pi r squared plus the lateral area, or pi r squared plus pi RL. And then the volume is 1/3 the base area, which is pi r squared times the height. So again, hopefully the cone's the easy one too. You're going to get given the height and the radius, or the height and the slant height, or the radius and the slant height, and you just have to use the Pythagorean theorem to get the missing segment. Worst comes to worst, they give you the diameter. You cut it in half and you have all the same information.
You're gonna be like from the one where it's like
No, not on the quiz. No, you'll probably see something like that on the test, but we'll save it for then. It's really straightforward. It's one pyramid, information about a pyramid, find the surface area, the lateral area, or the lateral area, surface area, the volume, and then you're going to get given a cylinder. Lateral area, surface area, volume, and then you get given a pyramid, same 3, and then a cone, same 3.
So for each shape, they ask the same question?
Correct. Alexis?
How many more lessons are there before you go?
2. So we're doing spheres and then similar solids, which means 2 more formulas, and then you'll learn about ratios of similar solids.
Should read it on the chapter.
That's why we divided it. Yeah. All right, so on the quiz,